power also by the load, regardless whether it is Y or it is delta connected. The real power is equal to the algebraic sum of the two wattmeter readings. So how can we prove that when we add W1 and W2, the total power will also be the same? Let's go to the next slide. Okay, so we all know from previous discussion that let's say we have a let's just assume that the load that we have is a resistive load and with an inductive load, right? So now this is the phasor diagram of this circuit. We have BAN. So this is our A, this is our neutral here, and BAN angle. So let's write BAN is equal to the B phase angle 0, and BBN is equal to the B phase angle minus 120 from this figure, and CN is equal to B phase with an angle of negative 240 degrees, right? And of course, you know also the BBC is an angle with an angle 90 degrees from this figure, okay? And here, BCA, it will be what? It will be what? So if this is 90 plus 120 here, right? It will be 210, right? 210. 210 plus another from here 120. So it will be 330. From here to here, this is 330, if minus 330, or we can simply say this 30 degrees with this, with respect to this measure. Now, observe P1. P1 is BAB multiplied by IA. BAB multiplied by IA. Cosine theta plus 30. So BAB multiplied by IA. So where is IA? We have a resistive load and inductive load from this impedance. It means to say we have a lagging current, right? So because this is a resistive and inductive, we have a lagging current. So we can say, we can assume that this is our IA, right? IA with an angle theta with respect to BAN, right? So with this case, BAB multiplied by IA, cosine, the phase angle between them is 30 plus theta. 30 plus theta. So, okay, since here is BAB, here is B line, and IA is also B line, we can simplify this equation as BL cosine theta plus 30. Okay? Now, let us go to our wattmeter 2. Wattmeter 2 is the voltage BCB, voltage coil BCB. So we have BCB multiplied by IC, which is also a line current. And what is the phase angle between them? Phase angle between these two is, if you have this BBC, right? So of course, we will have this, the BCB is on the other side. Let me just draw it. This is our BCB. Okay? And if here we projected that BAN, IA is lagging by an angle of theta, this is also our BCN. So we can put our theta here. The IC should be on this line. So IC with an angle of theta, which is also lagging BCN, right? It is lagging BCN. So now, what is now the phase angle between BCB and IC? So we can expand this. So we will have BCB has an angle of is equal to BL, right? With an angle of what? 90 degrees, right? 90 degrees. And we have IC is equal to IL with an angle of what? 120 minus theta. Right? Okay, let us now expand this equation. So P2 is equal to we can write BL, IL, right? Then cosine of, what is BBC here? 90. Cosine 90, right? Minus what? The phase angle of this IC is 120 minus theta. 120 minus theta. Right? And simplify this portion. We will have BL, IL, cosine what? Minus 30 plus theta. So we can rewrite this as P2 is equal to BL, IL, cosine theta minus 30, right? Which is now equivalent to this one. So let us add together. So what did we say? We say P1 plus P2 will give us P total, right? So let's go to the next slide. Okay, we know that cosine from trigonometry, cosine A plus B is equal to cosine A cosine B and minus sine A sine B. Okay? And cosine A minus cosine B is equal to cosine A cosine B plus sine A sine B. So we will substitute, similarly, we will substitute this in our equation. We can say that if we add P1 plus P2, this is P1. Okay? We factor out BL, right? This is for P2, this angle here. So cosine theta plus 30 is equal to cosine theta, cosine 30, minus sine theta, sine 30, sine 30 following this trigonometric identities. Plus, the other side, we have cosine theta, cosine 30, plus sine theta, sine 30. So you notice from here we can cancel out sine theta plus 30 because minus sine theta plus 30 plus sine theta plus 30, this will be cancelled out and we will have this part of the equation, but this is equivalent to 2, right? 2 of cosine theta plus 30 because they are the same, so multiplied by 2. Now incidentally, if we calculate 2 multiplied by cosine 30, it will give us square root of 3 BLIL cosine theta. Right? Okay? And the theta is the power factor angle. Theta here is the power factor angle. And so it means to say that we already proven that PT is our equal to P1 plus P2. Right? Because this is our, you still remember our general equation? P total is equal to square root of, right? B line, I line, cosine theta, right? This is our equation for the total power for the three-phase. Now, we add together P total minus P1 plus P2. P total is equal to P1 plus P2. Now let us see the difference between the power. P1 minus P2 is equal to BL cosine theta plus 30 minus cosine 30 plus theta, factoring out BL and IL. So observing this equation, we can have cosine theta, cosine 30. This is minus cosine theta minus 30. I can cancel this part of the equation, right? Now, I will have here sine theta plus 30. So, it will become negative 2 sine theta plus 30. And 2 sine theta plus 30 here, this is equal to 1. Right? 2 sine theta plus this 1. Now, to remove the negative here, I will exchange the position of P1 and P2 to make it positive. Positive. So, it will be P2 minus P1 will give me BL, right? IL sine theta. Okay? BLIL sine theta. And if you took the Q total for our three-phase is S sine theta, right? Is it equal to square root of 3 BLIL sine theta. So this meaning to say, if I just multiply root 3 on the P2 minus P1, it will be equal to this Q total equation, right? Q total is equal to square root of 3 P2 minus P1. Okay? So this is the total reactive power. So if you have a value already, P2 minus P1, just multiply by root 3, this will be equivalent to the Q total. Okay? Now, let us, from our power triangle here, we can have our tangent theta. Tangent theta will be equal to Q total over P total, right? What is our Q total? Square root of 3 P2 minus P1, right? Divided by the real power P1 plus P2. Okay? Now, here are P2 is all our wattmeter reading, right? This is also our wattmeter reading. Wattmeter reading 1, W1, W2, W1, W2. Now, from the values of W1, W2, you can know what type of load you are having. So let's say if P2 is equal to P1, then arc tangent theta will be 0. So if tangent theta is 0, it means to say you have a purely resistive load. Okay? Let's summarize here. Okay, here. Okay, let's go to this equation. If tangent theta, if P2 is equal to P1, we have a purely resistive load because tangent theta here will be come 0. Now, if P2 is greater than P1, P2 is greater than P1, we are going to, we can know that we have an inductive load. Why? Because, you know, if Q is positive, as you know, if Q is positive, we have what? Inductive load, right? If Q is negative, we have an inductive load. So what will happen, capacitive load? Because here, if P2 is greater than P1, meaning to say our power triangle will look like this. This will be Q total. This will be P total. This will be S, right? So if tangent theta will give me positive value. If P2 is greater than P1, this tangent theta is a positive value. That means to say Q total is positive. That means I have an inductive load. If P1 is greater than P2 or P2 is less than P1, what will happen? This will give me a negative sign, right? Negative sign. So if it is a negative sign, it means to say that your power triangle will look like this, right? So this one is Q, which is a negative, and this is S, this is P, and this theta. So if Q is going down, it means to say we have a capacitive load. And if Q here is going up, here we have an inductive load. Okay? Now, an application, of course, the power generated from power plant, okay, and it's transmitted through transmission line, and it will go to the customer. Okay, the wattmeter also being installed also in the, it is called kilowatt meter, kilowatt hour meter. Kilowatt hour meter is installed in the customer, and also of course from their power plant station, they want to measure the power, the total power that they generate and transmit to the customer. And this the wattmeter here, from the power plant will measure all the losses also until the plus the customer, all the losses plus customer. And here also we'll measure only the customer consumption, right?